GPS, or Global Positioning System, is a fundamental part of modern life. From navigation and tracking to time synchronization and scientific monitoring, we owe a great deal of convenience, comfort, and development as a species to it. But how does it actually work? The GPS consists of over 30 satellites in medium Earth orbit, which all go around the Earth about twice a day. Each satellite emits electromagnetic waves, specifically radio waves, and each has an atomic clock used to make very accurate time readings. Your GPS device is in constant communication with these satellites and uses a process called trilateration to pinpoint your location to within a few meters. To make this explanation simple and easy, I'll showcase this process on a two-dimensional universe. This is the Earth, and this is you on it with your GPS device. Your device then receives a signal from a first satellite, let's say satellite A. The signal includes, importantly, precise data on the satellite's location in orbit and the exact time the signal was broadcast using its atomic clock. This allows your device to calculate its distance, dA, from the satellite using its own internal clock and the speed of light. And using the exact position of the satellite in space, your device can infer that it must be somewhere on a circle around the satellite with a radius dA. But this obviously isn't enough to pinpoint your location. Your device doesn't know where on the circle it actually is. So your device then receives a second signal from a second satellite, satellite B. Your device, again, calculates its distance dB from this satellite and infers that it must be on a circle around satellite B with radius dB. But wait a minute, now your device knows that it must be somewhere on both circles, and therefore infers that it must be located on one of the two intersections. Now we're really making some progress. But the device still doesn't know which intersection it lies on. So it takes one more signal from satellite C, which gives it a circle which intersects the other two circles at one point. The point at which the device, and therefore you, are located. We had to use 3 satellites to locate you in this two-dimensional world. For our real 3-dimensional world, you would need 4 satellites. And imagine instead of circles, each satellite would have a sphere with a radius the distance calculated. The first 2 satellites as spheres would give a circle of intersecting points, and so on with each satellite, until one point remains the intersection of all spheres. The 4th satellite is also usually used to validate the other data and solve for any timing errors caused by the less accurate device clock. In reality, a modern GPS device will take signals from all visible satellites to improve its accuracy and precision. I hope this was useful. Thank you for watching.